Assalamu alaikum guys. This is plinth beam steel reinforcement construction. Size of this plinth beam is 12 by 16 inches. This is the junction between beam and column. You can see guys, this is short beam. This is end of this beam. You can see the steel reinforcement. They didn't provide any development length to connect beam steel reinforcement with column steel reinforcement to make a good bond between beam and column. Guys, you can see the upper portion steel reinforcement should be placed to the downward and the downward should be placed at the upward side to make a good bond between beam and column steel reinforcement, but unfortunately they didn't follow any steel structural drawing, so therefore they placed without designing. If you see guys, the beam, they used here 5 steel rods, dia is 12 mm, 3 steel rods at the top portion which is called compression zone and 2 at the bottom which is called tension zone. Unfortunately, at the bottom they didn't provide maximum numbers compared to its top portion because concrete is strong in compression, but they provided 3 steel rods in upper portion in compression zone, but concrete is weak in tension, but they provided 2. So this is one of the big mistake in the construction of this plinth beam steel reinforcement. They did the wrong design, so this is not the proper design. They just did the design by a steel fixer, so therefore they will face more problems in the future, because this is educational building which is 3-story. Size is 12 by 16 inches. You can see the plinth beam and the plinth level. On the top of this plinth level they will construct this plinth beam, then they will start brick masonry. You can see guys, the spacing of stirrups, stirrup dia is around about 6 mm, so which is minimum. This is lesser dia of stirrup, it should not be less than 8 mm. The spacing you can see, which is maximum, which is not the proper compared to structural drawing. You can see the hooks are bent on 90 degrees, so this is not the proper way to construct the plinth beam steel reinforcement. Now you can see they didn't provide any development length. On the other side you can see this is the long beam, that one was the short beam, but the design is same. You can see guys, they provided lapping here, so this is not the place to provide lapping, so it will provide cracks after some time, because the lapping is allowed to provide in upper portion or in compression zone in the beam. It is allowed to provide at the middle, but not at the distance of L/4. You can see at the end of the beam they provided the lapping, which is not allowed, and the lapping is depend on the dia of steel rod, and the lapping formula should not be less than 50D, where D is dia of steel rod. Guys, you can see that is short beam which length is up to 10 feet from center to center of each column. They did the same design. If that is long column or short column, they don't know the steel structural drawing. Actually, the size of the column steel reinforcement design is depend on the structural load of the building. Where we have maximum load, so the size and steel reinforcement should be changed compared to the place where we have the minimum structural load. So therefore, they didn't follow any rules regulation of this plinth beam. They just constructed and they will start its concrete after some days. Guys, you can see clearly. Size of the column is 12 by 18 inches. They used 16 mm dia of steel rod. Total they used 10 steel rods. You can see they didn't provide any development length. Even they didn't provide any extra steel rods or bent up bar to resist negative bending moment. They just wasted the time, and also they wasted the steel reinforcement in this construction. Guys, you can see that steel reinforcement will be placed when they complete its construction on the top of this plinth level. Then they will start concrete work and farm work. Hope this short video can help you. Thanks for watching. See you in next video. Goodbye.